बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम। हम पढ़ेंगे बाइनॉमियल थ्योरम और इस पर कुछ सवालात। Binomials. An expression in the form a plus b is called a binomial because it is made of two unlike terms. Any expression of the form a plus b having two terms a and b which are unlike. So any expression having two unlike terms is called a binomial expression. Here we see binomial expression raised to the power 2, raised to the power 3 and raised to the power 4. Here the exponent is 2, so its expansion will give us a series of 3 terms. Here we have a series of 4 terms, and for the exponent 3, here the exponent is 4, so in the expansion we will have 5 terms. If we study the series at the right hand side, here the exponent of a will start from 2 and it will decrease term by 2. Similarly, the exponent of b start from 0 and it will increase by 1 from the left to the right side. Here the exponent of a start from 3 and it will decrease term by term to the right side. Similarly, the exponent of b will start from 0 and it will increase from left to the right side. Moreover, in every term, the sum of the exponent of a and b will be 3. Since the exponent here is 3, so in every term the sum of the exponent of a and b will be 3. Here the exponent is 3. Here the combined exponent of a and b is 3. That is 2 plus 1 is equal to 3. So here the exponent is 3. Here the exponent is 3. If we generalize these information, then for a binomial expression of a plus b power n, we can say that there are n plus 1 terms. The first one is a power n and the last one is bn. The exponent of a decreased by 1 for each term and the exponent of b increased by 1. The sum of the exponents in each term is n. If we expand, that is, if we find the value of this binomial expression, we will see that the first term will be a power n, the last term will be b power n. The sum of the exponent of a and b in every term will be equal to n. If here is n, there will be n plus 1 terms to the right hand side of this binomial expression. So these are the information about the binomial expression with certain power. Here in the screen we see a binomial series. This is a binomial series and this statement is called a binomial theorem. Here in the left side we have a binomial expression raised to the power n. Here the number of terms are n plus 1. If we count the number of terms, this is first term, this is 1, so this is first term, this is 2, so this is second term, this is n, so this is the nth term, and if we include this term, the total number of terms will be n plus 1. Here in this summation the number of terms are n plus 1, whereas the exponent of the binomial expression is n. These are binomial coefficients, and we can find its value by a formula which we will see in the next slide. Here if we study every term, we will see that the sum of the exponent of x and y is n, and this n we see here. Similarly, the sum of the exponent of x and y in the second term is also n. That is n minus 1 plus 1 is equal to n minus 2 plus 2 is equal to n, 1 plus n minus 1 is equal to n. Similarly, the sum of the exponent is n. So the sum of the exponent of x and y in every term is n, and that n is lying here is exponent of the binomial expression. Here we see binomial series. This is a binomial series. Since here we see first term, the last term. Here the number of terms are finite because the exponent n here is a natural number. When the exponent is a natural number, then we will write a finite number of terms to the right hand side. To find the value of binomial coefficient, we can use this formula. We read this one is NCR, and its value can be determined by using the formula n factorial. This is NCR will be equal to n factorial divided by r factorial into n minus r factorial. This is the formula to find the value of binomial coefficient. This is the binomial coefficient lying in the first term. This is the binomial coefficient of the last term. If we expand value of both the binomial coefficient by using this formula, we will see that both of them are equal to 1. Here, if we name this term as t1, this term is t2, this is t3, then the name of this term will be tr plus 1. Looking to the first term, if here is 0, so here will be 1. If here is 1, here we will write 2. If here is 2, here will be 3. This is third term. If here is r, here will be r plus 1, r plus 1. This is the r plus 1 term denoted by tr plus 1, and tr plus 1 is equal to ncr a power n minus r b power r. This a is the first term of the binomial expression. This b is the second term of the binomial expression. This formula is used to write any term of our choice. We can find any term in the binomial series. This formula is called general term formula. If we put a is equal to 1, b is equal to x, and if we take the exponent n as a real number, then we will write this binomial series as 1 plus x power n is equal to 1. Value of the first term is equal to 1. Value of the second term is equal to nx. Value of the third term is equal to n into n minus 1 by 2 factorial x square, and the last term will go up to infinity. When n0, this n0 is equal to 1, or 1 power n is equal to 1, so here this is equal to 1. n1, if here is 1, then we will write n as a single factor. So n is a single factor. In the denominator we can write this one as 1 factorial. Since here is n and here is 2, so we will write this n as a product of 2 factor, and this 2 will go as 2 factorial in the denominator. Here, for the term here, we can write n as a product of 3 factor n into n minus 1, n minus 2, divided by 3 factorial, and we will write x cube, and in this way we can complete the binomial series. So remember this form of the binomial series as well as this form of the binomial series. This is a binomial series. This is the statement of the binomial theorem, or a is equal to 1, b is equal to x, and here the number of terms goes to infinity. It is on account of the exponent n, which is not a natural number but it is a real number. So we have to remember this equation, this statement of the binomial theorem. Binomial theorem can also be written in the sigma notation as this one, a plus x power n is equal to this one. This n minus k, this n minus k will be taken as exponent of the first term a. This k will be taken as exponent of the second term x. If we set a is equal to 1, if we take this a is equal to 1, we end up with the binomial theorem. To pair इसी binomial, then we can write this binomial series as 1 plus x power n is equal to n0, a is equal to 1, x power 0. If you take k is equal to 0, so 1 power n, x power 0, so we will get n0. Similarly, putting k is equal to 1, we will get this one. Putting k is equal to 2, we will get this one, and this is the last one. Power n is equal to k. Putting k is equal to n, this will be the last one. So this is a binomial series. This is another form of the binomial series. Now we come to the next slide. Finding binomial coefficients. We know how to find value of the binomial coefficients. Using that formula, we can find value of nc0 is equal to this is equal to 1. Value of nc0 by using that formula is equal to 1. Similarly, value of nc is equal to 1. So this is first this is the binomial coefficient of the first term. This is the binomial coefficient of the last term, and we see that both the values are the same, so we can say that binomial coefficient from the beginning and end have the same value. Similarly, nc1, this is the second binomial coefficient from the beginning, whose value is equal to n, and ncn minus 1 is the second binomial coefficient from the end side, and its value is also equal to n. Thus we can say that value of the binomial coefficient from the beginning and end have the same value. Both the values are the same, and both the terms are second from the beginning as well as from the end. This second coefficient and next to last coefficient will be n. So remember this statement that to write the binomial series for a given binomial expression, remember that the value of the binomial coefficient from the beginning and from the end will always have the same value. These are here 4,1. How to find value of 4,1? We will use that formula, and it will give us 4. This is the value of this 4 is value of this binomial coefficient. Similarly, this 6 is value for this one. This is the value for this one. Substituting x plus y power 4, x plus y power 4 का जो series है, to write the series for x plus y power 4, we can use either PASCAL triangle or we can use binomial theorem and the formula how to find value of the binomial coefficient. So after finding value of all the binomial coefficient, then we will put these values for binomial coefficient. This is value for n 40. Value of 4 is equal to 1. So यहाँ पे 40 की value है. This 4. This is the value for 4,1. This is the value for 4,2. This is the value for 4,3. This is the value for 4,4. Here the value for 40, for 4,1, for 4,2, for 4,3, for 4,4. Binomial to look at the expansion. If here exponent is 1, then the number of terms will be 1. If the exponent is 1, there will be 2 terms at the right side. If the exponent is 2, we will have 3 terms. Similarly, for 3, we will have 4 terms. These are binomial series for given binomial expression, and we can find the coefficient of every term either by using PASCAL triangle or by using binomial theorem and the formula for binomial coefficient. Looking to this formula, here is 1, 4, 6, 4, 1. In the PASCAL triangle, we have third row, we have zeroth row. In the Pascal triangle we have zeroth row, we have first row, we have second row, we have third row, we have fourth. So the values of these coefficients can be obtained by Pascal triangle, and by using the third row in the Pascal triangle. So this one will be here again 1 or 3. To add 1 3 we will put here 4. 3 plus 3 is equal to 6, 3 plus 1 is equal to 4, and this will be 1. So we can write any formula here with the help of Pascal triangle or to use binomial theorem. The binomial theorem. Recall that a binomial has two terms. Here we have two terms, so it is a binomial expression. The binomial theorem gives us a quick method to expand binomial raised to power such as power 0, power 1, 2, 3. For this binomial expression, we will start from 1. Then we will write 1 here and 1 here. Similarly, we will write 1 here, 1 here, and between these two 1 we will put sum of 1 and 2. 1 plus 1 is equal to 2. Similarly, यहाँ पे we will write 1 here, 1 here. 1 plus 2 will be equal to 3. 2 plus 1 will be equal to 3. Similarly, to complete this row, we will write 1 here, we will write 1 here. 1 plus 3 is equal to 4, 3 plus 3 is equal to 6, 3 plus 1 is equal to 4. To complete the last row, we will write 1 here and 1 here. We will add 1 with 5 will be equal to 6. 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6. So we see here a triangle. This triangle is called Pascal triangle. This triangle is called Pascal triangle, named after mathematician Blaise Pascal. Notice that row 5 comes from adding up row 4's adjacent numbers. The first row is named as row 0 or 0th row. What will be row 6? This row 6 can be obtained by using 5th row. This pattern will help us find the coefficients when we expand binomials. Pascal triangle. In the Pascal triangle, in this line we will write 1. Similarly, in this line we will write 1. And between this line and this line we will do some calculation. We will add adjacent numbers and we will place diagonally here. Looking 0 0, this is equal to 1. This is place par 1. 1 0 is equal to 1. Similarly, 1 1 is equal to 1. This is another. This is the third row. So for third row we place here 1. This one is equal to 2 0. 2 0 is equal to 1. This here is 1. So for 1 we can write 2 2. How we will obtain this one? Since here is 1, here is 1, so add. Taking this 1 and add 1 with 1, we will get 2. And take the greater between these two consecutive. इन दोनों consecutive में से बड़ा लेना है. 1 हम यहाँ पे लेंगे. दोनों 1 1 है तो 1 के साथ 1 ऐड करें तो 2 आएगा. अब यहाँ पे 2 0 का मतलब है 1. इस तरह 3 0 का मतलब है 3 0 का मतलब है 1. 3 3 का मतलब है 1. अब 2 2 सेम है तो 2 के साथ 1 ऐड करें तो 3 आएगा. 3 आएगा. अब इन दोनों कंसेक्यूटिव में से बड़ा यहाँ दर्ज करें. 2 2 सेम है तो 2 के साथ 1 ऐड करें तो 3 आएगा. दोनों कंसेक्यूटिव में बड़ा ले ले 3 लिया. ये रो मुकम्मल हुआ. अब यहाँ 1 है तो 1 की जगह हम 4 0 लिख सकते हैं और ये 4th रो है. इस वजह से यहाँ पे हम 4 0 लेंगे और यहाँ 4 4 लेंगे. दोनों ये बाइनॉमियल कोएफिशिएंट है फॉर फर्स्ट टर्म और ये बाइनॉमियल कोएफिशिएंट है फॉर लास्ट टर्म. अब दरमियान में जितने भी बाइनॉमियल कोएफिशिएंट हैं ये हम किस तरह मालूम करेंगे। 3 और 3 सेम है तो इसके साथ 1 ऐड करें तो 4 आएगा और दोनों में से बड़ा यहाँ पे लिखे। 3 3 सेम है तो 1 ऐड करिए 4 होगा और दोनों में से बड़ा यहाँ लिखे। 3 3 सेम है तो 1 ऐड करिए 4 होगा और दोनों में से बड़ा 3 ले लें। अब इसी रो को मुकम्मल करने के लिए हम क्या करेंगे, ये 1 के लिए दिस प्लेस इज पावर 1 सो वी कैन मोर ओवर दिस इज द 5th रो सो राइट 5 0 एंड 5 5। अब दरमियान में जितनी भी बाइनॉमियल कोएफिशिएंट इसकी वैल्यू हम मालूम कर सकते हैं। 4 4 सेम है तो 1 ऐड करें 5 हो गया, दोनों कंसेक्यूटिव में बढ़ा ले तो 1 लिया, दोनों सेम है तो 1 ऐड करें 5 हो गया, दोनों कंसेक्यूटिव में से बढ़ा ले। इस तरह सेम है तो 5 हो गया, दोनों में से ग्रेटर यहाँ लिया। सेम adding 1 with 4 we will get 5 and taking the greatest term between these two which is 4 so 4 is here. So this is the PASCAL triangle. ये एक PASCAL triangle है और PASCAL triangle की मदद से हम किसी भी बाइनॉमियल सीरीज को लिख सकते हैं। Find the following binomial coefficient. इसी बाइनॉमियल कोएफिशिएंट की वैल्यू हम फार्मूले की मदद से मालूम कर सकते हैं और ये जो फार्मूला था वो हमने पढ़ा। 8 दिस 8 फैक्टोरियल हो गया और 8 से 2 माइनस करें तो 6 फैक्टोरियल हो गया और ये 2 फैक्टोरियल। अब 8 फैक्टोरियल का हम लिखेंगे 8 ज़रबे 7 ज़रबे 6 फैक्टोरियल। 6 फैक्टोरियल इस वजह से स्टार्ट किया कि नीचे भी 6 फैक्टोरियल है, दोनों हम कैंसिल करेंगे तो 8 और 7 आएगा और नीचे 2 फैक्टोरियल आएगा। यहाँ 8 है यहाँ 2 है तो 8 को हम इसी 2 की वजह से एज अ 2 फैक्टर लिखेंगे और ये 2 नीचे 2 फैक्टोरियल होगा और कैलकुलेशन से ये हमें सिंप्लीफिकेशन से हमें 28 देगा। इसी तरह 10c3 बाई फार्मूला ये 10 फैक्टोरियल होगा, 10 से 3 माइनस करो तो 7 फैक्टोरियल और 3 है 3 फैक्टोरियल। अब इसी 10 को हम एक्सपेंड करते हैं तो 7 फैक्टोरियल तक इसकी वैल्यू हम लिखेंगे यहाँ तक और फिर 7 अपनी जगह पे 3 फैक्टोरियल अपनी जगह, दोनों को कैंसिल करेंगे। यहाँ 10 है यहाँ 3 है तो इसी 3 की वजह से इसी 10 को हम एज अ प्रोडक्ट ऑफ 3 फैक्टर लिखेंगे और इसी 3 को हम नीचे 3 फैक्टोरियल लिखेंगे और उसको हल करेंगे। इस तरह 7 3 तो 7c3 इसी 3 की वजह से इसी 7 को हम एज अ प्रोडक्ट ऑफ 3 फैक्टर लिखेंगे। 7 6 5 और 3 का मतलब है 3 फैक्टोरियल या 3 to 1 ये वैल्यू है। 7c4 इसी 4 की वजह से इसी 7 को हम एज अ प्रोडक्ट ऑफ 4 फैक्टर लेंगे, 7 से शुरू करेंगे और 4 तक लेंगे और 4 का मतलब 4 फैक्टोरियल तो ये 35 आ जाए। ये तो हमने अभी पढ़ा। नेक्स्ट स्लाइड में हम जाते हैं। यूज द 4th रो, ये क्या है 4th रो, दिस इज 4th रो। This is 4th row. Use the 4th row of PASCAL triangle to find the numbers in the 5th and 6th row of PASCAL triangle. ये 4th है, इसी 4th की मदद से 5th row और 6th row मुकम्मल कर। तो ये तो ऑलरेडी हमने पढ़ा। इसी 1 को हम इस तरह कंटिन्यू करेंगे, इसी 1 को हम कंटिन्यू करेंगे, फिर 1 और 4 का मजमूआ 5 आ गया, 4 और 6 का मजमूआ 10 है, 6 और 4 का मजमूआ 10, 4 और 1 का मजमूआ 5। इस तरह 1 और 5 का समेशन 6, 5 और 10 15, इन दोनों का 20, इन दोनों का 15, इन दोनों का 6। तो इसी तरीके से हम पास्कल ट्रायंगल को कंटिन्यू करते हैं, कंप्लीट करते हैं। द बाइनॉमियल थ्योरम, हियर वी सी अ बाइनॉमियल थ्योरम। दिस इज द बाइनॉमियल थ्योरम whose first term is here. This is actually nc0 x power n y power 0. The first term here is actually nc0 x power n y power 0. This last term is actually ncn x power 0 y power n. This is the first term, this is t2, this is t3, so this will be tr plus 1. This term is tr plus 1 and this term is called general term. ये तो अभी हमने पढ़ा। Remember, this term is called general term. It is denoted by tr plus 1 and we will always use this formula to solve different type of question. थैंक यू। इसी पे हम एक और वीडियो बनाएंगे।